A common property of the D block elements is their tendency to form the coordination compounds. So whenever you deal with the coordination compounds, basically we have salts. The simple salts can be mixed to get double salts or the coordination compounds. So let's take an example. Copper sulfate, which is a salt, is now mixed with ammonia, so that you are getting an addition compound which is represented as CuSO4 4NH3. Similarly, let's take KCl, MgCl2, which is mixed in water to get the aqueous solution, and after drying the substance you are getting the crystals, and that is represented as KCl, MgCl2, 6H2O. So basically this is carbonate. So any compound resulted after drying, the crystals is called the addition compounds, or addition compounds are also known as molecular compounds. Now you have two types of addition compounds, CuSO4 mixed with NH3 or KCl with MgCl2. Now let's analyze, are they having equal identity in the aqueous as well as in the crystal form. So when you take CuSO4 4NH3, in the aqueous solution we are expecting the ions copper 2 plus, SO4 2 minus and ammonium ions, so that whenever you are going for the test you should get the positive result. But it is observed that they retain their identity even in the aqueous solution, indicates they are present. CuSO4 4NH3 is actually represented as CuNH3 4 times, which are existing as a pair, and that there is sulfate ion which is present outside of the sphere. Therefore, now the ammonia which is present in the system is no more free, rather it is in the combined form with the copper, and hence they are retaining their identity both in their crystal state as well as in the aqueous solution. If you consider carbonate solution, let's take KCl, MgCl2, 6H2O, this is the crystal dry form. Add water and take the aqueous solution, so that now you are getting K plus, Cl minus and Mg2 plus. So how you are understanding K plus, Cl minus, Mg2 plus are present in the system, go for the test, you will get the positive result. So that indicate KCl, MgCl2, 6H2O in the dry form has one form, whereas in the aqueous solution they are not retaining their identity, they lose their identity, they exist in the ionic form. So such compounds which lose their identity is called as double salt, whereas the compounds like copper sulfate 4NH3 which retains their identity even in their aqueous solution is called as coordination compounds. So we are going to deal with the coordination compounds. The basic terminology involved in the coordination complexes are the complex ion, central metal ion, coordination number, coordination sphere, oxidation state and the ligands. So whenever you consider a complex ion, you have the set which is associated with the ligands as well as a metal ion. So basically the metal ion is a D block element. So complex ion is formed by the aggregation of a central metal ion along with their ligands. Central metal ion may be D block element, so most probably it will be D block element. P block element is also possible. Coordination number is actually the number of surrounding ions around the central atom. If you consider the example CuNH3 4 times SO4, as the central metal atom copper is surrounded by 4 ammonia, the coordination number should be 4 because it is the total number of sigma bonds around the central metal atom or ion. Now what is a coordination sphere? The association of the metal ions along with their ligands results in the formation of a sphere which is written in bracket, and that is called as coordination sphere. And outside the coordination sphere, in order to balance the charge, if the coordination sphere possesses any charge, then that is called ionization sphere. Oxidation state is important whenever you consider D block element or any metal which forms a compound. When you consider this example CuNH3 4 times SO4, let's split the ions. The ions which are present in the aqueous solution are CuNH3 4 times 2 plus and SO4 2 minus. So that indicate now the coordination sphere is with the 2 positive charge. So that is actually the result of the oxidation state. It should be the sum of oxidation state of copper plus plus the charge given by the for ammonia. So as you know, NH3 is a neutral molecule, therefore the total charge given by ammonia should be 0, which indicate the 2 positive charge on the coordination sphere is actually the oxidation state of the metal atom. So whenever you consider the metal atom or metal ion, oxidation state is important to represent a coordination compound. The last terminology used in the coordination complex is ligand. A ligand is an electron-rich species which are able to donate the electrons to the vacant orbitals of central metal atom. So when you consider this coordination sphere, CuNH3 4 times 2 plus, 4 ligands are surrounding copper. That indicate, okay, let us consider copper at the center and you have 4 ligands surrounding the copper. Why NH3 is acting as a ligand? Because it's a Lewis base, is electron rich. So you have electron pair which are available for donation. Copper 2 plus being a d block elements has enough empty orbitals so that they are able to take the 2 electrons donated by the ligands. Therefore any ligand will be electron rich substance which are able to donate the electrons from its filled orbital to the vacant orbital of the central atom. These are the basic terminologies involved in a coordination compounds. Now let's go for the types of ligand and how you are classifying the ligands.